We want to show that the two lines below are skew. We have r equals 2, 4, 1 plus t, 3, minus 1, 2, and r equals 5, 6, minus 4 plus t, 1, minus 3, 3. In 2 dimensions, there is only one possibility for two lines not to intersect. They must be parallel. If we have two parallel lines, they're like train tracks. They go on forever, but never intersect. In 3 dimensions, however, there is another possibility. The two lines are what's said to be skew. We can see with these two lines that they're not parallel. Look at the direction vectors. Clearly, they don't go in the same direction. You can see they're not the same, nor is one just a multiple of the other. So if these two don't meet, they must be skew. So what's meant by skew? Consider this box to be the room you're sitting in, and if it helps, actually turn around and look at your room. We could have one line going across a diagonal of the floor, and another going across the diagonal of the room as shown. These lines clearly will never meet, and they're not parallel, so they must be skew. So let's examine the situation. For the two lines to actually intersect, i.e. for them to meet, we must have a point where their x-coordinate, their y-coordinate, and their z-coordinates are equal. That means we should be able to find a value of t and a value of s that makes the x-coordinate, the y-coordinate, and the z-coordinate for both lines the same. So let's consider the coordinates. If we look at the x, we get 2 plus 3t is 5 plus s. We'll call this equation 1. The y-coordinates give us 4 take away t is 6 minus 3s. The z-coordinates give 1 plus 2t is minus 4 plus 3s. If we add equations 2 and 3, and I've chosen these because we have the same number of s's, but a different sign, we get 5 plus t is 2, which tells us that t is minus 3. Substituting back into either of these equations gives us that s is minus 1/3. So we've solved these two as simultaneous equations and found that t is minus 3 and s is minus 1/3. Since we used equation 2 and equation 3, we know that the y and z coordinates are the same when t is minus 3, and of course that means when s is minus 1/3. 2 related the y coordinates and 3 the z coordinates. So finding a value of t and a value of s that works for these two tells us that the y and z coordinates are the same for these values of t and s. But of course for the lines to meet, we need the x-coordinates to be the same as well. So we need to check the x-coordinates. Looking at the left-hand side, that's the 2 plus 3t, and using this value of t, we get minus 7. Now looking at the right-hand side here, and using this value for s, we get 14 over 3. These are not the same, so the lines are skew. In other words, we found a value of t and a value of s, where the y and z coordinates were the same, but the x coordinate was different. If we look at the diagram of the room again and set up an x-axis, a y-axis, and a z-axis in our room, what we found is this position. If you look at the two lines, their y and z coordinates are the same here, but the x coordinate is different.